So this brings us to our final section. And here again, what we're going to do is we're going to take our new classical model and we're going to change an exogenous variable and then see what the effects are on the endogenous variables. But now instead of changing government expenditure, we're going to change technology, Z. And I'm using the term now that's used in the literature, I'm calling this a technology shock. There's a sudden change to Z. Okay? And when that happens, what are the effects on our endogenous variables? So recall that new classical economists see business cycles as being the result of changes in technology. I mentioned this once before in the business cycle facts lecture. But remember, these new classical economists came around in the 70s and 80s and they said, the earlier Keynesian view that recessions are due to insufficient aggregate demand is incorrect. Instead, these fluctuations in the economy that we see, say by passing an HP filter through series and looking at the fluctuations around trend, those fluctuations are probably driven by technology, changes in that parameter Z, or technology shocks, which here I defined as random fluctuations in Z. What might cause these changes in Z? Well, it's never totally clear, to be honest, but we might have some ideas. Okay, so inventions, for example, something that makes us more productive suddenly for any given amount of labor or capital. Okay, so that could be an invention. Could be changes in resource prices. Okay, so if suddenly oil is really inexpensive and I'm a net consumer of oil to produce, plastic, then if suddenly oil becomes cheaper, well, suddenly I'm more productive, right? I can produce more for a given amount of capital and labor. And, you could also think about good weather if, say, you're very agricultural, you're a farm, okay? Or changes in regulations, they might change the cost of doing business and so on. So these are, some ideas of what the new classical economists had in mind. And the resulting business cycle models are called real business cycle models. So that is, these are fluctuations being changed by this real side of the economy, being changed by productivity, being changed by sort of the cost of doing business. And so these are called real business cycle models. I put this in blue because it's maybe an important term to know. Okay, so what happens in our model when we increase Z? So again, we're going to do it graphically. Okay, so and once more here, we're going to deal with the social planners problem. Okay, so we're not going to deal with the budget constraint. We're just going to look at the PPF, the production possibilities frontier, and the indifference curves. Okay, so here's our PPF1, I'll call it. And suddenly Z changes, suddenly Z increases. What does that mean? It now means that for any amount of labor, I can now produce more. And really what it ends up being is this rotation up of the PPF. Okay? I mean, it's a rotation up rather than a shift up because still at leisure zero, I can produce nothing. And so you have this rotation upwards. I'll put a little arrow showing. And so, again, the consumer then picks some new point of optimality given by the tangency of its indifference curve and the PPF. Or that is, the social planner does that. If it was the consumer, we would have to draw the budget constraint and so on. But given that the solutions to the two problems are identical, here we work with the social planners problem. And so this is PPF2, production possibilities frontier 2. Okay, so what are the results? Well, consumption obviously goes up. Why? Notice that this rotation upwards is equivalent to an increase in the wage in the consumer's problem. And so as a result, there's both an income and a substitution effect. Now for consumption, these are going in the same direction. right? The income effect means I have more income and therefore I consume more. And the substitution effect is now consumption is cheaper and so I consume more. So both effects are going in the same way. Now, for labor supply or for leisure, the two being, the flip side of the same coin, we don't know. Why don't we know? Well, again, it comes back to this income and substitution effect. So in one case, there's an income effect saying I'm richer now. And so because leisure is a normal good, I want to consume more of it. And if I want to consume more leisure, that means labor supply goes down. Well, on the other hand, now the wage is higher for sort of any amount of labor. And so the cost of leisure goes up. And therefore I want to consume less leisure and more labor supply. And so you have these two effects going in different directions. And on the whole, without knowing the production function or the utility function, we don't know what the total effect will be. And so here I put a question mark for labor supply. What about output? Well, obviously output goes up, right? I mean, we have this increase in Z, we have an increase in C, G hasn't changed. So to put it another way, you can think about this. Change in Y is equal to change in C plus change in G. Okay, change in C is positive, change in G is 0. So this means that the change in Y must also be positive. W, what happens to the wage? Well, you won't be surprised to know, and I'll show you in a second a proof of this, but you won't be surprised to know that in this model, the wage goes up. Why does this make sense? Well, now for any amount of labor supplied, the wage that the firm is willing to offer is higher. Why? Because now the marginal product of labor at any point is higher. Or to think about it graphically, for any amount of leisure or labor, the slope of the PPF is now higher than it was before. And so, you could think about it in the following sense. This is probably the easiest way to visualize it, is think about it in our goods market, our labor market, not our goods market. An increase in the marginal product of labor for any amount of labor demanded, for any amount of labor is the same as a shift up or a shift to the right in the labor demand curve. Remember, we saw that in the theory of the firm. And so evidently what's going to happen then is we'll have an increase in the wage. And so that shouldn't be surprising. But I'm going to show you, I'm going to come back to that slide, I'm going to show you here sort of a small proof of how we know exactly that the wage increased. Okay, so recall, as I said, there are two effects, right? There's the substitution effect, which leads labor supply to go up, and there's the income effect, which leads it to go down. Okay, now imagine we could separate these effects. And I'm going to show you in a second that graphically, in fact, we can. We can separate the two effects graphically. So what do I mean by separate these two effects? Well, imagine we have a line like this, okay? Here's where I was initially supplying labor, N0. Now we have this increase in Z. Okay, and that's going to have two effects. So imagine the first effect is this substitution effect right here. And that means that my labor supplied is going to go up. I call this N sub. So that's the first effect. And then the next effect is the income effect, which is going to move me in this direction. Okay, so we'll say to here, and I'll call that N1, because that's going to be the sum total of the two effects, right? The movement from here to here, that's the substitution effect. And the movement from N sub to N1 is the income effect. The addition of the two is the total effect, okay? So notice that N sub, that is the amount of labor I work after just the substitution effect, has to be greater than or equal to N1. Okay, you see it also here. That's what we saw there. And because I have a downward sloping labor demand equation that looks like this, that means that Here's my N sub. Here's my N1. That means that the wage, the wage I end up with must be greater than the wage if I just had the substitution effect. Okay, and that's what I put here. Why is this important? Well, imagine I could show the following. So we have that Wn1 is greater than or equal to Wn sub. And I'm about to show you that we can show that Wn sub is greater than my initial wage. And so taking this logic together, what does that mean? It means that my new wage must be greater than my initial wage. Okay? How am I going to show that? I copied this graph from the textbook because I didn't even want to try to draw all these lines. But let's go through it piece by piece. Okay, piece one is the following. I'm going to tell you that the movement from point A to point D is the substitution effect. Okay? Why? How do we determine graphically what the substitution effect is? The substitution effect graphically is the following. So here we have our initial production possibility frontier, which is then rotated up. The substitution effect is saying, take that new production possibilities frontier and shift it down until it is exactly tangent with the initial indifference curve, I1. Okay? The point at which it's tangent to the initial indifference curve is point D. And so therefore the movement from A to D is the substitution effect. And you'll notice that, as we expect, this is a decrease in leisure or an increase in labor supply. Okay, so point D is our substitution effect point. So now the next part of my proof is I have to show you that the wage at that point, let's go back here. I want to show you that the wage at that point, N sub, is greater than the initial wage. How do I show that? Look at the following. What was the wage at the initial point? It's given by the tangency of the PPF there, which is equal to the marginal rate of substitution at point A. Okay, so wage 0 is equal to the marginal rate of transformation at point A, which is equal to the marginal rate of substitution at point A. What's the wage after the substitution effect? So when we move to D. Well, it's the same thing, right? It's still, and I'll call this W sub, is going to be equal to the marginal rate of transformation at point D, or the marginal rate of substitution at point D. Now notice that as we move along this indifference curve, what's happening is the slope is becoming higher. And so that means that MRSD is greater than MRSA, or W sub, the wage after just the substitution effect, is greater than W0. And so now I've shown what I wanted to show in this last slide, right? Is that W sub here is greater than Wn0, and therefore Wn1, so my new wage, must be higher than that. And so I've shown you, therefore, the wage must increase. Now I realize this is kind of a complicated proof, but it's worth seeing. Oh, I have to go back now to this. Okay. So does this match the business cycle facts? Right? Remember, these new classical economists claim that this is what's driving the business cycle, is these changes in technology. So one way to evaluate this is to say, okay, are the changes we're seeing in the economy, do they make sense given what we know about changes during the business cycle? Or put another way, do the business cycle properties we're seeing in the model match the business cycle facts we saw in an earlier lecture? Well, let's look at them. So in the data, consumption is pro-cyclical. And in the model, consumption is pro-cyclical, right? So if Z is what's driving these business cycles, well, when Z goes up, consumption goes up. And when Z goes down, consumption goes down. And so therefore, an increase in C is associated with an increase in Y, and so therefore it's pro-cyclical, right? We saw in the model when Z goes up, both C and Y go up, and therefore C is pro-cyclical. What about the wage? Well, in the data, again, the real wage is pro-cyclical. And in the model, what did we see? We saw that when Z goes up, okay, Y goes up, and W goes up. So therefore, it's pro-cyclical. And what about labor? Hours worked. In the data, again, it's pro-cyclical. We saw this. And what about in the model? Well, in the model, we don't know, right? Because in the model, we have when Z goes up, Y goes up, and there's both a income and a substitution effect, and on the whole, we don't know if it goes up. Now, in fact, in dynamic models, so that is those models where we don't restrict to just have one period, N does end up being pro-cyclical, okay? Hours worked does end up being pro-cyclical. Why? Well, assume that increases in Z are somewhat temporary. Okay, that's the assumption that's usually made. And that's why it's called a shock as well. It happens, but it's kind of temporary. It goes away over time. So that means that today, if Z is high, well, tomorrow Z is likely going to be lower. Okay, it's this temporary shock. And so that means that today the wage is going to be high and tomorrow it's going to be not so high. So if I was smart, what I would want to do is work today while the wage is high and then work less tomorrow when the wage is low. Okay? And this is called intertemporal substitution. I'm substituting labor across periods. I want to work more when the wage is high and work less when the wage is low. So what does that mean? That means that now when Z goes up, W goes up. And I know that this increase in W is slightly temporary. It won't be as high tomorrow. And so I'd better work today. And so that means that in this case, we'll have Z goes up, Y goes up, W goes up, and therefore when W goes up, I will also want to work more. And this will lead to pro-cyclical labor. And I say more on this later because, again, this is a dynamic model. Right now, we're just looking at the static model. Can we test this hypothesis more directly? So right now, what we said was, okay, does this fit the business cycle facts? Okay, so I'll go back one more time here. What we really looked at is if Z is driving these changes in Y, these changes in output, do the other endogenous variables, so here I have consumption, wage, and labor, do they also fit these business cycle features? But something else we might want to see is, well, does the increase in Z imply an increase in Y? Right, so are these fluctuations we're seeing, are they actually associated with increases in Z technology? Well, in some sense, it's kind of hard to answer, right? Because it's hard to measure this technology. I even said in an earlier slide, I mean, we're not even always clear what it is, right? But one way to do it is to use what we call the Solow residual, okay, named after Robert Solow, a name you might recognize from the first lecture. So this is the Solow residual. Imagine that output is produced in a Cobb-Douglas way. Okay, so that's the following. Y is equal to Z times k to the alpha, n to the 1 minus alpha. Well, what's nice about that is if that is the production function for the economy, then we can measure k, we can measure capital, we can measure labor, and we can measure output. And so if we measure all of those things, we can easily back out Z just by this equation I have here. So it's the residual because it's the part that can't be explained by k and n, right? So if we see an increase in Y, for example, but K and N didn't increase at all, well, then that increase must have come from Z. Or alternatively, if K does increase and N increases, but Y increases more than we would expect given the production function, well, then that additional increase in Y must be caused by Z. That's the logic here. And I put here, this is kind of important, is that we'll get good estimates of Z if and only if we have a good representation of the production function. And this comes back to something we saw in an earlier lecture as well, that really a lot of this is based on having the right model, right? If in fact the true model of the economy is very different, we might arrive at incorrect conclusions. Okay, so if we do find that solar residual in the way I just showed you, and we plot it, we detrend it, as we saw before, and we plot the percentage deviations from trend with those of GDP, we can see that, in fact, it does follow GDP very closely, right? It's definitely pro-cyclical. And not only is it pro-cyclical, I mean, it matches very well these changes in GDP. And so this is another piece of evidence then that new classical economists would point to saying, aha, see, changes in Z are associated with changes in GDP. Not only that, but changes in Z also lead to the changes in endogenous variables that we expect to see over the business cycle. We saw that in an earlier slide. And therefore, taken together, this is a very good indication that probably changes in Z, changes in technology, or these technology shocks, are what are causing the business cycle. That's the argument. Well, we might have some questions, as you can imagine. One, what exactly is causing these technology shocks? Right? We kind of talked about some things before, but I also told you that it's not always clear. There's no way to look specifically. And I'll claim here that some cases a technology shock isn't a great explanation for what we see. So imagine, I'll go back to the graph here. Here's 2009, the Great Recession. We have this huge drop in GDP relative to trend and also a huge drop in the solar residual, so in technology. So we might ask, what was the technology shock that caused the 2009 downturn? Why was it that firms in aggregate suddenly became less productive? And is that a good explanation for what happened? The next question is the correlation between the solar residual and GDP, is this actually causation or is it just correlation? Right? It could be that the two are related because of, say, some third factor or some other reason. Or maybe it's changes in GDP are causing changes in the solar residual. And so on that point, this is my point here. So for example, recall that surveyed businesses suggested that their unit cost falls as their output increases. We saw that in the last lecture. So put another way, as I increase my output, it's true that for a lot of businesses, I become more productive. My unit cost falls. I become more productive. And one outcome of that could be that that's picked up as an increase in the solar residual. Right? That appears to be an increase in technology, for example. Because as I'm increasing more, I become more productive. So when GDP goes up, I become more productive. And so in that case, the causation goes the other way, doesn't it? Increases in GDP cause increases in technology or in productivity, not vice versa. And finally, is Cobb-Douglas the right production function? I mean, again, I guess I said this already. It could be that the production function is something very different. And so these changes in Z that we're seeing are being driven by a misspecification of the model.